As software engineers, we have all come across these terminologies: availability, scalability, performance, security, robustness of any software system, right? What are these? These are architectural characteristics, or in simple words, these are the capabilities a software system should have, right? This is at very high level. But um, if you have not understood these terminologies as in architectural point of view, then this session is for you. Here we will understand what are actually the component capabilities, software architectural characteristics, how do we use them in a real architectural building while we are building the solution, right? Example, banking system again, right? Um, every day everybody obviously use bank, right? We manually go to the bank, make all our transactions, and we are done with the work. Now, when we want to implement this banking system using software, right? Now, the requirement here is the banking system. We should be able to make transactions, credit, debit, um, transfer, transaction history, fraud detection, all of these are the requirement of the banking system, banking software system, right? What the system is doing, right? Another example, food ordering system. So what is the original way of doing? We all go to restaurants, order our food, then we have the um, food. That is our usual way, right? Now, if we want to implement this system in terms of software application, right? So, what is the requirement? The requirement is we should be able to place our orders, get the delivery, right? So, this has many operations in between. So, now, in nutshell, the banking system, the food ordering system, right? These are all the domain requirements of the system. What is the domain? What the system is intended to do? What system is all about, right? This is one aspect of requirement. Now, when we have a banking system, we have some expectations out of that banking system, right? There is a banking system. We are able to make transactions, right? Now, the very minimum basic requirement can be availability, right? Um, if the system itself is not available, how do I even make my transactions, right? I have the software implemented and it is up and running. At some point of time, it is not available. Then what is the use of building this software? There is no use, right? Now, um, disaster recovery or continuity, right? So if there is any incident or some unexpected event, the system is down, right? Now, how soon it can recover back and continue to serve the customer? These are all some of the non-domain requirements of the system. There is a domain requirement, there is where we define what the system should do. This should do my transactions. This should serve banking customers, should allow all the debit, credit, all the facilities that a typical bank is giving. This is one part of requirement. The other part of requirement is it should be available. It should be scalable. If I have to serve, maybe tomorrow, today I'm serving 1,000 customers, I have to serve 1 million customers, then that should be scalable. It should not be restricted to only 1,000 customers, right? Again, compare it with a real banking system, the physical bank, right? There is never a restriction on only these many people I'll serve, right? So it should. almost try to mimic the real world with software capabilities. That is the whole idea. So now today's focus is on these characteristics which are defining the non-domain requirement of the system. This is called architectural characteristics. These are not domain requirement. These are capabilities of the system which are out of the domain requirement. Yeah, now we understand architectural characteristics in three different aspects. Right? One, as we already mentioned, these are non-domain, non-domain, right? So the domain design considerations cover the behavior of that system, and architectural characteristics define the capabilities of that system. Okay. Now, when we combine these two together, these define the structural design of the system, what the system is doing and what is the capabilities it can handle. These two together become the structural base foundation of the design. Right? The second important thing to understand the architectural characteristics is an architectural characteristics influences some structural aspects of the design. That means when we say that this system is providing example security, right? So there are two ways to look at it. In real world example, see if you are building a simple application, right? So how do you tackle the security? You bundle everything together. That is monolithic architecture. Then you provide some encryption or hashing, some security policies upfront when the user is making the call. So this is handling the security now, right? Now here we are not specifically talking about security, or the security is not changing the structural behavior, right? So we have chosen the architecture. We are as a minimum requirement, we are implementing security, right? Now, if we move from monolithic to microservices architecture, right? Monolithic to microservices. Now, the security constraints must be distributed to all the modules, right? Now, in monolithic, we had only few constraints and we were able to handle the security in simple ways. But in microservices, there are more constraints that we need to take care. There is a security layer which is applied to the incoming user, right? There is security which we should handle between components. When microservices, we have different components talking to each other, right? Now we should handle the security between the components as well, right? Now the security aspect is getting more complicated. So it is affecting the structural design of our architecture, right? Again, one more example is scalability. Again, in monolithic, we cannot scale monolithic system beyond an extent, right? After some point of time, we have to switch to another software architectural patterns. Say again example, microservices. Now, how the architectural characteristic is impacting here, right? Now, when we were in monolithic, we we were having issues, right? Issues handling more customers or more traffic per hour, those kind of issues. Now, scalabilities are architectural characteristics. To achieve scalability, we got to move from monolithic to microservices. That means the scalability software architectural characteristics is demanding the structural change. To achieve scalability, we need to change the structure of our system. Right? This is how the architectural characteristics impact structural changes. Right? So that is our second point. It should impact structural, influence structural changes. The third aspect of understanding architectural characteristics is it should be critical and important. Say in real world example, what we expect from the system, right? It should be available. It should perform at its best. It should be scalable. It should be highly secure, right? As much as the characteristics we add, we are happy. We are moving towards ideal system, right? Um, but this is the trap, right? When you try to implement or fit everything into one system, the system starts getting complicated. So, um, the best way to choose a particular characteristics that we are expecting from system is by measuring it how important it is, how critical it is, so that system is at its best, but it is at the same time it is not complicated. Right? Example, if you are trying to achieve scalability, right? So what do? You deploy your system or application in multiple um, servers or using more infrastructure, basically, right? Now, if you're also focusing on availability, right? Now, to make that system, the highly scalable system, highly available, so what is the way? So the infrastructure, you should be able to double the infrastructure. Because, for example, if you are deploying your application on A and B, two servers, right? Now, your system is scaled between A and B, and your system is available from A and B. Now, you're also trying to scale it. So, what you do, you extend your system to A, B, C, right? Now, how do you make it highly available? So you should have replicas of A, B, C, right? If one goes down, the other serves. The application on A, same for B and C. So when you try to achieve availability and scalability, both, so what are we losing here, right? We need more infrastructure. And if you are achieving the security, right? Security. Now the security between the components gets complicated. There are more components, there is more security layers added. The more distributed it is, there is more security aspects, right? When you try to fit all of them into one single system, it starts getting complex. Now we lose whole domain requirement when we are only focusing on making the ideal system in terms of architectural characteristics. So as an architect, you should be able to make a judgment in such a way that for any given system, what is a main or a critical important characteristics, capability it should provide, and try to optimize or work towards those characteristics. It should definitely serve the domain requirement along with few of the architectural characteristics. So this is the key for every architect. So this is how we define architectural characteristics. To summarize, it should be non-domain requirement, and it should influence some structural changes. Then it should be important and critical. We have to choose and implement those architectural characteristics. Thank you for your valuable time. In the next sessions, we will continue exploring more software architectural topics. This session is part of software architecture series. There are more concepts covered on all the other topics of software architecture. Please take a look. Thank you.